Hi everyone, welcome back to another session by K21Academy. And today our expert trainer will be discussing about taints and tolerations. So make sure you're watching the video till the end.
So what is tainted toleration? Node affinity has a property of pods that attracts them to set of node sites. We have seen this one as preferred way or hard requirement. That is a node affinity. But taints are exactly opposite to the node affinity, right? They allow a node to repel a set of pods that you don't want to put the pods on the specific worker node. If you don't want to put the pod on a specific worker node, you can taint it, right? So that is the meaning of it, right? So taints are the opposite. They allow a node to repel a set of pods. What is the toleration? Tolerations are applied to pods. So let's say that 100 pods are there, and out of that one pod you want to deploy on that particular tainted node. So you need to write a toleration definition inside the deployment YAML file of the pod. And you need to tell to the worker node, look, please accept this pod. You can tolerate this pod. Taints and toleration work together to ensure that pods are not scheduled onto inappropriate nodes. Right? So how do we taint the node? So this is the command which you can see, kubectl taint node, and how you can tolerate the pod so that it can be deployed on the tainted node by adding this toleration definition. You can add here like this. So deploy the pod on the worker node whose toleration is this type is equal to magnetic and effect is no schedule. Okay, so wherever you find the node whose effect is no schedule, that do not schedule any pod, and where is the label is used, this type is equal to magnetic. If this particular tainting information is there, then deploy the pod on this one. Deploy the pod on the worker node where this toleration condition is exists. Let us discuss about what are the different toleration effects are there. Tainting effects are there. Let me explain you that. Taint effect and operators. So effect. One of the effect which you see that no schedule. No schedule is the thing, but do not schedule the pods on the tainted node. New pods that do not match the taint are not scheduled onto the node, but the existing pod remains as it is. Okay, so if you have 50 pods running and you have applied the taint on that worker node, then new pods will not get deployed, but the existing pods will run as it is. Prefer no schedule. This is another effect that you can use, another keyword that you can use. What is the meaning of that? New pods that do not match the taint might be scheduled onto that node, but the scheduler tries to not to, and the existing pods on the node remain as it is. So what is the meaning of this? Meaning is that it is similar like hard limit and soft limit. So we use a preferred during scheduling and ignore during execution, right? Similar way we can do. Even the pod worker node is tainted, you can still deploy the pod in case it is used as a soft limit. No execute is nothing but what? New pods that do not match the taint cannot be scheduled on that node, and the existing pods on that node that do not have matching toleration are removed. So this is used for the eviction policy. If you want to evict the pods from specific worker nodes, you can do that. From the tainted worker nodes, you can use the effect called as a no execute. So no pods will get scheduled on that one, and the existing pods will get removed also. So that is what no execute means. There are operators now. There are equal and exist. These two operators are there. And you can see what is equal means. The equal key value effect, all three parameters must match. This is the default value. So the key is this type, value is magnetic and effect is no schedule. All these three, if they are matched, then only that node will get, that toleration will get affected, right? Otherwise it won't. That pods will get deployed on the particular tainted worker node if this toleration definition is defined inside the pod manifest. Exist key is nothing but similar like you see the operator equal, though there is a exist operator is also there. Exist operator is nothing but it is an operator which is need to be defined inside the toleration part. And if that exists, only then that will get tolerated. So if your disk type exist magnetic, okay, then only don't schedule it, right? That is the meaning of it. So both the operators will be used for the same purpose. So let me see that the more information. I'll just give the more information about the exist as well. Okay, this is the way we have to write the pod that I have shown you. So what happens? No schedule taint means no schedule. If you use this command on the worker node, kubectl taint node worker one, this type is equal to magnetic and no schedule. So this is the label you can say that you are applying. This is the taint you are applying on the worker one. Then what happens? This is the way you can, if you deploy the pods, okay, with the container called as nginx, the pod C1 gets created and it will get created on the worker 2. It will not get created on the worker 1 because it is tainted one, right? You can create the set of the pods on the worker 2 and worker 3, but not on the worker 1. Once it is, no schedule is deployed. No pod will get deployed on the worker 1. That is a no schedule. Taint and toleration, no schedule. I think, let's say that this is again a same example. And where you write here that is, okay, tolerate the pod who is having this particular information. So what will happen? This worker one is basically having a label called as, or taint called as, this type is equal to magnetic no schedule. And we are saying with the help of this YAML file, please deploy this one on the worker one. So tolerate this pod, even though there is a problem, but tolerate this pod. That is the meaning of this particular definition. So what will happen if the pod gets created? It will get created on the worker one also, even though it is tainted, because it is matching the toleration condition. That is the meaning of toleration. No execute is nothing but what? You are given the tainting property as kubectl taint node worker one, this type is a magnetic, no execute. So you try to deploy the pod using this manifest. Then what will happen? On the worker one node, no pod will be scheduled, but all other pods will get scheduled here. But whatever the pods are there, existing pods here, they will also get evicted from this location, right? So that is the meaning of no execute. So do not execute any pod, do not deploy any pod, do not schedule any pod, as well as do not execute any pod on this worker node if it is tainted as like this one. Okay, so let's see these examples now, how taint and toleration can be applied. Kubectl K deployments. I hope that everything is down. No, it is not deleted. Kubectl delete deployment called as nginx deployment. And let me delete this as well so that we have a fresh machine. There are no pods running, right? So we can understand it better. Okay, so everything is getting terminated now. How to now taint the system? Kubectl taint. Which node you want to taint? Let's say that you want to taint the worker one. And what is the property you want to use? You want to use the property that is called as, okay, so we can see here this type is equal to magnetic. This is the, yeah, we'll use the same thing so that it will be easy for us to use the same YAML files. So you can see that it shows that worker one has been tainted now. It says that no schedule. So kubectl create deployment called as app1, right? And hyphen image is equal to nginx. So I'm deploying a new application over here. And you can see that since this particular node has been tainted, which one? Worker one. So normally pods will get deployed on worker 2 only. So let me scale up this kubectl scale deployment app1 hyphen replicas is equal to 5. And now see that application has been scaled, and see all of them have been now running on the worker 2, because my worker 1 is in the tenting condition. That's why it is not deploying the in further pods, right? So now if I want to remove the tent, how we can remove the tent, guys? You can use this command kubectl taint node. Just use minus, and you can see the worker node has been untainted. And if you try to find out again the information or describe the node, you can see there is no taint. Okay, and now if I try to scale up the application to the, let's say, 8 replicas, you should be able to see now on the worker 2 as well as worker 1, because taint has been removed. Okay, so let me bring back the taint again on the worker 1, so that we'll see that how now existing pod behaves. So tainting is done by like using this command. Let me describe this, and you see that it shows that taint is equal to this type is equal to magnetic and no schedule. So, but have we labeled this particular worker 1 as this type is equal to magnetic? Kubectl, but yeah, it has been tainted, right? So it has been labeled like that. Kubectl get nodes hyphen show labels. This is my worker 1, and see this worker node has these labels are there, right? This type is equal to SSD and this one, but the taint is given is this type is equal to magnetic no schedule. This is the label as well as taint has been given. So if I use kubectl describe worker 1 only and try to get the information, more information about this one, you can see here the value of the taint. Somewhere it will be available. Okay, so value is about, this is a condition, this is the address, this is the capacity, and you can see here this is the taint. So label and taint is different, guys. So it is tainting with the help of label with the, and it is giving the label called as this type is equal to magnetic, and what it is saying, no schedule. Let me taint the existing node along with the no execute policy, right? You don't use the labels, right? For that one, you use the taint value. So let me try to now use the another. Okay, so what I will do, I will just remove this taint from this one now. Okay, so still the pods are running, right? The pods will not have any issues. So pods are running on the worker 1. There are almost 3 pods which are running on the worker 1. Now what I want to do, I want to taint again this worker node, but this time I want to use some different value. Instead of no schedule, I want to use no execute. Okay, so that is the no execute. This is the property I'm using. This is the value I'm giving it to the tainting. Now you can see that it is tainted. You can find out more information about the taint. That is, this type is equal to magnetic, no execute. No schedule is nothing but it will not schedule the further pods. But what has happened? Let's see that with the no execute command. Do you see some changes, guys, here? All the pods have started running on the worker 2. So that means everything has been evicted. Which pod was running on the worker 1? This pod was running, right? Look at it. It has been changed. New pod has been come up. Yes, new pod has been started on the worker 2. So whenever you use a keyword called as a no execute, so all the pods, existing pods, will also get evicted from the worker 1 tainted node, and it will start on the another node. Now we have to use a toleration. Now we have understood the 2 values, right? No execute and no schedule values. Now we want to write a toleration so that the pod will get scheduled on the tainted node. So how do we do that? So let me see that if I have a script for it, guys. So I have a toleration here, toleration pod. Let's try to, yes, this is a script. So vitt1.pod. Okay. -pod1.yaml, and you can see here we are trying to deploy the new pod or deployment as well. You can use the deployment also, guys. There is no problem. But inside the container, you have to write this property toleration. And where you want to deploy this one, where this type is equal to magnetic and no schedule is the effect is no schedule. But there is one more key value is assigned now. Let me first of all try with this one and then we'll add another one. Let's see what happens. See guys, worker 1 is having now two values of the taint. One is no schedule and no execute. Both of them are already applied on the worker 1. And now I am using only one value, toleration value, to deploy the pod inside the worker node. So let us see that whether it gets deployed or not. It is created, but where it is created? kubectl get pods -void. It has got created on the worker 2. It has not created on the worker 1. Actually, we wanted to create this on the worker 1, but it has got on the worker 2. Why? Because there is another condition is there, right? Taint condition, which we need to specify it inside this one. So let's see that how we can specify. So we have understood that how we can use one key, but how to use multiple keys. I think this will help us to understand. So this type is equal to magnetic only, but effect is no execute. Let me save it. It has created, that means it is taking a multiple key values. Now let's see that where it is now getting running. Yeah, see here, it has started on the tainted node. So the condition is satisfied and the pod is started on the worker 1.
So guys, this was our expert from Team K21 Academy, and if in case you want to have a deeper dive and want to build a career in Kubernetes and Docker, including DevOps, then we have something really special for you. We have our free class on mastering Kubernetes, Docker and DevOps that includes how to build in-demand skills and land a higher paying job. So for that, you just have to visit k21academy.com/K8S02. You have to click on book your free seat now. And after that, select an event date according to your availability. Enter your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of interface. You just have to save this link on the extreme right, add it to your calendars, and I'll see you in the free class. Till then, take care and keep learning.